Good afternoon, everyone. Over the next 20 minutes, I want to cover what's happening about DNS over HTTPS across standards, browsers, resolvers, ISP trials, and the key impact areas to watch. So, starting with a background slide, as I'm sure we're all aware, is domain name system is all about mapping friendly domains into IP addresses. And this dates back to the IETF standards from the 1980s, and it's important to remember that all of this data is sent unencrypted. But being network engineers, ISPs also use DNS information to support wider service capabilities. For example, routing customers to local content caches, offering broadband personalized content filtering and malware protection, so there's wider use of it more than just domain name resolution. It's also worth noting that currently the majority of internet clients use the serving ISP's DNS by default. You've probably heard about the different flavors of encrypted DNS. So the first one is DNS security. And this is all about just verifying that the DNS answers you receive are genuine, but it doesn't encrypt the actual flow. The next one is DNS over TLS. This encrypts the DNS requests and response, and it does this for a dedicated flow on a dedicated port, so it's separate from other device traffic. Then you're going to come on to DNS over HTTPS, which I'm going to focus on today. And this also encrypts DNS requests and response, but cleverly it mixes them in with HTTPS on port 443 to make them indistinguishable. I believe the adoption here is going to be driven very much by the applications, but I believe network operators and the wider ecosystem need to evolve to support all of these options. So, what are the key DNS functions and models in the DoE ecosystem? So, starting on the left-hand side, you've got the clients, the browsers and applications, and the operating systems generating the requests. Now, there's two support models here. There's the default on approach, and this is where the likes of Mozilla, Firefox Mozilla in the US, are defaulting on to a centralized DoE resolver. In the US, this is Cloudflare. So that's model one. Then the second model is one which Chrome and Microsoft Windows are proposing. And that's different because here they're proposing to only upgrade customers to use DNS over HTTPS if they can detect that the existing DNS provider supports DoE. So it's a same provider only automatic upgrade. Then looking on the server side, the DoE recursive resolvers, there's two different support models here. You have your traditional distributed ISP resolvers, and these can be either closed, where they're only available just to the ISP customers on the ISP's networks, or you can have them open where they're available to all. Then you've got the centralized cloud resolvers, likes of Cloudflare, others, Google, etc. And all of these are open to all public resolvers. And at the moment across the industry, we're seeing circa 40 DoE providers which are openly available at the moment. So what's the latest on the browser status and operating system support for DNS over HTTPS? Starting with Firefox, Mozilla. They started a phased rollout of default on in the US to Cloudflare, and they started this in September last year. They've recently added NextDNS as an additional DoE provider. We're also pleased to see that they have supported the capability to detect existing ISP policies through a canary domain approach. And they're not presently planning to enable a default on approach in the UK. Then moving on to Google Chrome. Chrome started experimenting with DoE functionality in Chrome 79. We now understand that they're targeting Chrome 82, which is targeting stable version in April this year, for DoE privacy and security capabilities. And as I mentioned on the previous slide, they're focusing on a same provider auto-upgrade behavior, which will only automatically upgrade if an existing provider supports it. They will also add manual configuration options. In terms of Microsoft Windows, they're taking a very similar approach. They're doing early experiments around Windows DoE capabilities, but are considering an approach where they will default on to DoE if the existing DNS provider is recognised as supporting DoE. Apple are also pushing several proposals into the IETF around DoE discovery. Okay, so where are the IETF with DNS over HTTPS? Yes, we have the RFC 8484 standard, which covers the requests and responses, but this only does that. It doesn't cover fully the wider customer experience angle, the application, the operator aspects, for example, DoE discovery. However, it's great to see on Friday evening the Internet Engineering Steering Group in the IETF confirming that they have formed a new working group called Adaptive DNS Discovery to tackle this issue around DoE discovery. I've included in the link here, and I would encourage people to get involved in the mailing list discussions and attend or remotely the IETF 107 meeting, which is happening towards the end of March. It's also worth noting that other industry alliances and associations are also exploring DNS over HTTPS. A couple of call-outs here. The first one is the Encrypted DNS Deployment Initiative. They're currently defining user cases and deployment guidelines for DNS over HTTPS. Closer to home, the UK ISP Association, ISPO, are currently exploring a UK model policy for trusted DoE resolvers. The European Telecommunications Network Operators, ETNO, have recently published a positioning paper on DoE. And if you're a member of the GSMA, I would encourage you to get involved in their discussions. So, what is BT doing on DoE? Since early December, we've been running an experimental DNS over HTTPS trial. Currently, we're testing it just across a limited base of BT employees and the IETF and industry community. It's built on and working with Open Exchange powered DNS capabilities. Presently, it's only supporting IPv4 to maintain parity with our broadband offering. And it's only implementing the RFC 8484 implementation, so it's not supporting the JSON API. At the moment, it's a public open resolver, so anyone can access it. However, if we were to move to productize it, we are likely to move it to a closed resolver. And we're shortly planning to add DNS security validation to it. I now want to move on to some of the key impact areas that I believe network operators need to consider around DNS over HTTPS. The first one is the lack of a DoE Discovery Protocol. As I mentioned earlier, at the moment, Microsoft Windows and Google Chrome are planning to use an IP address lookup table against the current public-facing DNS resolver, DNS over 53, and then do a lookup table to say, does that operator support DNS over HTTPS? The catch is, this will only reach a subset of the broadband base, because many ISPs deploy stub resolvers in their hubs, which only present private IP addresses to the clients, which will mean that, in that case, Google Chrome and Microsoft's Windows will not be able to resolve that to say, oh, it's a BT customer. So this is why we're calling out for the need for the IETF to work on developing a standardized context-aware DoE Discovery Protocol, which works for all scenarios. It also needs to be context-aware, so devices and users have the capability to set a DoE provider when they're on their broadband network, a different one when they're in coffee shop Wi-Fi, and another one, potentially, when they're on a mobile network. So that's the first impact area. The second impact area is Wi-Fi captive portals. Many Wi-Fi captive portals rely on customers using DNS over 53 at the moment. So does this open up a security gap? How do the captive network systems, can they aid this by not allowing any access beyond this until the sign-up is completed? And we are hoping that a lot of these issues will be addressed for the IETF Kapoor group. but it's an impact area that people should be considering. The next one, which is probably most interesting to this group, is the impact potentially to on-net content caches. ISPs and CDN vendors have invested considerably in on-net content caches to give the best customer experience and minimize network costs. However, those solutions which use DNS routing information, this could be impacted if certain DoE cloud providers block the passage of eDNS 0 client subnet information on privacy grounds. And we're yet to see an industry answer to this problem. So that's the third impact area. The next impact area is DNS-based content filtering. Presently, most UK ISP broadband customers can set their content protection once and then rest assured that all their home devices, smartphones, tablets, game consoles are all protected in terms of content controls and malware blocking. However, with DNS over HTTPS, as this is more application-based and on an individual browser, will customers risk an inconsistent experience here? Will they have to do different settings on different applications and browsers? Also, will customers realise that if they change to a third-party DoE provider, it may bypass their existing ISP content filtering? Now, it's great to see Mozilla recognising this issue and proposing the use of canary domains to detect existing policies, and then, if they detect that, then to disable the auto-enablement. But this capability is only at the moment available for the auto default on. We believe it also needs to be considered for manual entry. And also the approach needs to be standardised. Next area is the impact on court order and regulatory blocking and cybersecurity. Looking at regulatory blocking court orders first. URL and domain blocking are the most granular tools in the ISP kit box for blocking, for example, for court orders. However, if the UK ISPs are no longer in the DNS path, this could significantly impact the effectiveness of these capabilities. And does it raise a question that instead, will a court or regulator need to approach a collection of third-party DoE providers who may be based outside local jurisdiction? However, as I mentioned before, it's reassuring that Microsoft Windows and Google Chrome are taking the same provider auto-upgrade only capability, and this gives us confidence that around the continued use of existing ISP DNS filtering in the short to medium term will be effective. Next one is cybersecurity. DoE is very much a double-edged sword. Great for the customer in terms of added privacy and encryption, but it also is great for the hacker because it gives them new ways to hide their command and control. Will it open up new significant attack opportunities? Also, as more customers move to using third-party DNS, will it reduce the ISP insight gained from passive DNS information? Next area I want to come on to is the impact on customer support and performance benchmarks. Looking at customer service first, I mentioned at the start, ISPs may also use DNS redirects for service support, for example, setting up a new home hub. Or if a customer runs out of mobile credit, we use DNS redirect to send them to an account page where they can purchase a top-up. How will these be impacted by DoE? Then the other angle you need to think about is if you've got a customer which might have DoE enabled on, say, Firefox and Chrome, but Internet Explorer, they're using normal plain text DNS, and other applications is using the operating system DNS default. How do you troubleshoot that when that customer say, oh, one particular browser stopped working, or one particular application? Who are they likely to ring? They're still likely to ring their ISP. Put yourselves in the shoes of that ISP's customer support. How are they going to explain to the typical customer what DNS is, let alone what DoE is? And then if they can identify it's a DNS issue, How are they going to troubleshoot that when it's a third-party entity, potentially? So there's lots of customer service issues to consider. Now I want to move on to the performance of DNS over HTTPS versus DNS over 53 and share some of the results from the early BT trial. Many results so far have shown that there's not a significant difference between the performance of DNS over 53 and DNS over HTTPS. However, some early results from us are showing it could be a bit more significant than that. Early results from curl are showing that we believe that DoE has a greater latency due to the TLS setup. But there's some early caution about these results because we're taking the worst case scenario here of we're running a TLS session per DNS query. And we expect in reality the browsers will probably keep a TLS session up for multiple queries. So it's very much a worst case scenario. And on that basis, we're currently running some tests with Sam No's white boxes to get a more accurate view of the comparison of DNS over 53 versus DNS over HTTPS. Also on this topic, I want to touch on industry performance benchmarks. A lot of the Ofcom measures for broadband, like the web browsing speed, latency, DNS resolution, DNS failure, they're all DNS related. Fine when the majority of your customer base are using that DNS from that ISP. But do we need a new approach here if a larger number of customers are using third-party DNS? Also, do we need to break out and distinguish between DNS over HTTPS and DNS over 53 performance? Also, if we've got the bonnet open up looking at this, should we also consider the wider impact of HTTP3 and quick on these performance metrics? Next area I want to cover is the additional capacity overheads. We ran some curl measurements of a BT broadband line going to popular domains, and we compared the use of the cloud DoE providers, Google and Cloudflare, which are using TLS 1.3, with the traditional ISPs DoE capabilities using TLS 1.2. And you can see from the results there's a general view here that TLS 1.3 adds an additional overhead. Hence our recommendation that we would encourage people, if they're adopting DoE, to look to use TLS 1.3 as the standard. Another area I want to cover on is the impact on server capacity from DNS over HTTPS, because this is key from a business case perspective. And we're seeing some early interesting results here. Assuming a worst case scenario of all the traffic moving across to DNS over HTTPS, then we're seeing that this could drive the server capacity overhead up by circa 2 to 3 times to what we're seeing now with DNS over plaintext 53. And this is showing us that we potentially need to be looking at hardware accelerators. So again, that's early measurements findings. Next impact area is we're seeing variations in TLS DoE settings. So here this is suggesting that it would be beneficial for the industry, for the IETF and the likes of EDI, to issue best current practice guidelines. So some of the interesting results here. The first one is on OCSCP stapling. We seem to be the only ones which are doing this. So does this raise a question? Why are others not doing it? Are browsers not checking the status with CAs? Then the next one is session duration time. Yes, everyone's using 7,200 seconds, but as DoE takes up, will this need to be lower? Will it need to be 0? Then the next one is really interesting. Ticket session duration. We're down at 300 seconds. Google and Cloudflare are 2 days. Next DNS is 7 days. Why the variation? Why are some so long here? Is there a balance between privacy and performance? Then if you look at the cipher choice, there's variations again here. So here we're highlighting the need for best current practice guidelines. Then the last one, impact area we're calling out, is around cookies and namespace guidelines. We're seeing through the trial the user interfaces and policies may not be clear as they could be about how cookies are handled across browsers and DoE databases. We seem to be seeing that the browser side mentioned cookie for DoE's domains. We're seeing the option to remove cookies for our DoE capability, Cloudflare, Google, and DNS. We assume this is due to visiting the domain itself, but we would welcome interface clarity on which cookies are present in which databases, and confirmation that browsers are not sending or accepting cookies in the DoE messages. So here we believe this further clarification again is needed through best current practice guidelines. And we should be adopting an approach where clients should not be accepting set cookie as a part of the DoE response. Clients should not be sending cookies that they previously learned for on the domain, and DoE servers should disregard cookies. Then the last point is, if you look at the domain names, we've gone for doe.bt.com. Cloudflare have gone for cloudflare-dns.com. Why have Cloudflare gone for the hyphen? Is that for added privacy? Does this again highlight the need for best current practice guidelines? So in conclusion, there's good direction in the DoE ecosystem with more resolvers becoming available, the browser support and trials. However, many open issues still exist, many of which will hopefully be a benefit from the creation of the new IETF ad working group. But we believe a standardized DoE Discovery Protocol is essential and needs to be context aware. And it needs to consider the scenario where DNS stub resolvers are using hubs with private IP addresses. We're also seeing variations in DoE and TLS settings. So we see there being a clear need for best current practice guidelines. We're calling out the need to do more comparison work around DoE versus DNS over 53 performance. And lastly, we all need to remember, DoE is not just about browsers. ISPs and network operators need to start considering now applications, IoT, and device aspects of DNS over HTTPS. Thank you for your time. Any questions?
Any questions for Andy? Oh, one at the back.
Hi there. Just a matter of interest, what does BT see as the business case for DOH? Because primarily, I mean, it's for privacy's sake, nothing else. Do you see it as something which customers will demand, or is it just something given its disadvantages to you as a service provider, or what?
We see DoE as offering clear benefits in terms of privacy. So we recognise that the industry is moving more and customers are expecting more in terms of security and privacy and encryption. And we see DoE as being one capability to provide that. So we are supportive of DNS over HTTPS in terms of that capability. However, on the flip side, we are saying there's still areas of unintended consequences which need a lot further work on.
Yeah. We've got another question down here, Andrew. Hi, you had a little throwaway down at the bottom right of one of the slides that said clean feed will not be affected, and we're desperately trying to remember why not. Can you go into that, or do we need to continue our researches?
A number of people have asked, clean feed is more DPI based, so that's why it's not impacted. It's DPI based rather than DNS impact.
Thank you. Any last questions? Okay, thank you very much.
Thanks.